Today we are going to talk about segments and circles. Okay, so there's three different relationships that we have. They're easy problems, but you have to understand the difference between them. Okay, so let me just show you the three differences first, and then we'll get into what kinds you have. So first, you're going to have two chords inside of a circle. Okay, so just two lines in your circle. Then you're going to have it where there are two lines that both go out of your circle. Okay, so two secant lines. So these are two chords, two secant lines, and then a secant and a tangent. Okay, they all have different relationships. But again, you're going to either have two inside, two that both go outside, or one that goes outside and one that doesn't, one that just touches the circle. Okay? So let's talk about the two chords that intersect inside. The relationship is that each piece of the chord multiplied together is equal to the other two multiplied together. So it is that CE times ED is equal to AE times EB. It's as easy as that. Part times part equals part times part. Just as long as you're multiplying the same chord together, that's what you do. Okay, so let's do example 1. We want to find the value of x. So my first chord is this chord ST. Okay, so my equation is going to be first part of ST, so SQ times QT, and that is going to be equal to the product of the other two parts of the chord, PR. So that is going to be PQ times QR. Okay, so part times part equals part times part. So now we plug in what we know. SQ is X times QT, which is 8, and that's equal to PQ, which is 6, times QR, which is 4. So X times 8 is just 8X, and that's equal to 6 times 4, which is 24. Divide both sides by 8, and you get that X is 3. And that's it. Okay, so that's the first one. If you have two chords that intersect, you have, you multiply them together. Okay, now let's look at the next one. So the next one is when you have two secant lines. And this one's a little bit different. The equation is whole times outside equals whole times outside. Okay, so what I mean by the whole is AE, this whole thing, times just this outside piece. So AE times BE is equal to this entire thing, CE times DE. Now let me ask you something. If I knew AB was 4 and BE was 3, what would the whole thing be? 7. So that means if they tell you CD is X and DE is 2, this whole thing is not 2X, it's 2 plus X. Okay, so remember, you're adding these things to get the whole thing. A lot of you guys want to put 2X. That is wrong. You add them together. Okay, but here it's whole times outside equals whole times outside. So let's do the next example. We want to find the value of X. So this is two secant lines because both of them go through the circle. So it's whole times outside equals whole times outside. So let's look at arc RT first. And we'll set up our equation. So the whole thing is RT times the outside, which is RS. And then we look at the other segment, RQ. And that is whole, the whole thing, RQ, times just the outside, which is RP. Is anybody confused on what I mean by outside? It's the segment that's outside the circle. Okay? So what's the length of the whole thing RT? 10. And then what's the length of the outside segment? 4. That's RS. Now we need the whole segment RQ. What's the whole segment RQ? Good. X plus 5 or 5 plus X, same thing. Put that in parentheses, guys. And then we multiply that by RP. So what is the outside? 5. So we multiply this together. 10 times 4 is 40. And that's equal to, now remember, with this expression, you have to distribute the 5 into the parentheses. Okay, don't forget about that. That's why I had you put it in the parentheses. So when you distribute, you do 5 times 5, which is 25, plus 5 times x, which is 5x. And now this is a normal expression that you can solve. So you subtract your 25 on both sides, and you get 15 equals 5x. And then you divide both sides by 5, and you get that x is equal to 3. And now it wants you to plug it back in to find this each secant segment, meaning the whole thing. So we already know RT is 10, and then if x is 5, RQ is what? Or 3. If x is 3, what's RQ? 8. So any questions on example 2? Yes, ma'am. No? That's only if these two lines were tangent. That is, so she asked if they were equal. So that is when you have a circle and you have two tangent lines outside. So let me show you. Oh, no. So you want tangent lines to just like meet. See how these go through the circle? These are secant lines, so tangent lines are the ones that are equal. Got it? Okay. Okay, and then the last one is when you have a secant and a tangent. Okay, so the secant's going to go through it, the tangent's just going to touch it. This is whole times outside, so just like what we just did, so the whole thing times the outside is equal to the tangent squared. Okay? So secant lines are going to be whole times outside, and then the tangent squared. Okay, so let's do the next example. We have a secant and a tangent. So this is whole times outside, so the whole thing is SQ times the outside. What segment is my outside? RQ. And that's equal to my tangent line, PQ, squared. Okay, so whole times outside equals tangent squared. So what is the length of SQ, guys? 9 times the length of my outside, which is RQ, is what? 4. And that's equal to PQ, my tangent, x squared. So 9 times 4 gives you 36. That's equal to x squared. What do I do to get x by itself? Square root both sides. And when you do that, you get x equals 6. That's it, guys. Those are the 3 things we're going to do today. So if they're chords, you multiply each piece. If it's two secant lines, whole times outside equals whole times outside. Secant and tangent, whole times outside equals tangent squared. So go ahead and do these 3 on your own. Should take you maybe 2 or 3 minutes. I'm going to call on different people to help me out with them. Which one am I going to do? So what are the lines in here? Well, look at the examples. Which example am I going to match it to? I'm going to do with these chords. How am I going to set up my equation? So let's look back. How did I set this one up? Okay, so what did I do with this whole segment? What did I do with it? There you go. So AE times EB equals, do the same thing to the other chord. There you go. Okay, so what's AE? Times EB, which is? Equal to DE, which is? Times? 6 times 5? Okay. And then 8 times X? 8X. 30 divided by 8. Do you have a calculator? Okay, it's 3.75. Okay, so for the first one, guys, you should get 3.75. Does anybody not get 3.75 for X? Alright. Let's see. Asher, did you do B?
Yeah,
How'd you set it up?
I did, GJ times GH.
GJ times GH, good job. Equals?
GL times GK.
Okay. So what's GJ? Z plus 13 times what?
13.
And that's equal to?
30 times 9.
39 times 9. Because the whole thing's 39. So then you distribute the 13 in?
Yeah, and that gives you 13B times 169.
Okay. And then 39 times 9?
351.
Good. And then what do I do next?
Minus 169.
Yep, so subtract the 169.
And you get 13B is 182, and you divide it by 13.
Good job.
And you get 14.
Let me see, divided by 13. Yep, 14. Thank you. Yes, ma'am. Yeah, like you had 30 times 9 equals Z plus 13. Yes, that's totally fine. Yes. You don't have to do the letters for the homework, no. Alright, for the last one, who wants to help me with the last one? Go ahead, Janessa. How did you set it up with the letters? Okay, hold on. DF times DE equals DG squared. Okay? So DF is? Good. And DE is? And that's equal to? Good. So I distribute the 7 in. Well, what's 10 squared? There you go. So $7.29. That's fine. Alright, so